last video of lesson 4.1, and we finally get to talk about this GCF. If you remember from middle school, GCF stands for greatest common factor. This is yet another tool that you'll need in your tool belt in order to be able to successfully move forward with equations that are more complex than just your 2x plus 3 kind of stuff, your linear stuff that we've dealt with before. We're getting ready to start looking at quadratics and exponentials more deeply, and in order to do that we have to have some extra tools. So greatest common factor. Remember that a factor is anything that's being multiplied by something else. That's what we use the word factor for in math. Finding GCF. This is something you've done before, but there are three basic steps. First, you find the prime factorization. Prime factorization is this thing we call a factor tree. It's basically saying what are all the prime numbers that you would multiply to get the number you started with. All right, and I'll show you how to do that in just a second. Then the second step is you're going to identify the factors that are present in each number. So that are present in both of them is what we mean by that. What are the shared factors? So in this example, they both have a 2, they both have a 3, and they both have another 3. This one's got this 2 here, but there's not one to pair it up with over here. This one's got this extra 3, but there's nothing to pair it up with. So the only things that are shared are a 2, a 3, and a 3. And then the last thing you'll do is multiply the common factors together. So 2 times 3 times 3 is 18, so the GCF of this example would be 18. All right, so let me show you one that's got some variables in it and might be a bit more complicated. The first thing you're going to do is start your factor tree. I like to start off by splitting my coefficient and my variables. If you've got variables, it's best to go ahead and break those apart because we know that this is 12 times v squared. All right, so there's multiplication in between those. Then v squared is v times v. So I'm going to go ahead and break those apart. And then I can come over here to my 12. Now guys, there's more than one way to do almost every one of these problems. 12, you could write 2 times 6. You could write 3 times 4. One of them is not wrong. They will both work. You should probably write a 4 that doesn't look like a 9. But they'll both work. It doesn't matter. Then I'm going to keep going because 4 also has a 2 times a 2. So this 3 continues to come down, the v comes down, and this v comes down. So that my prime factorization of 12v squared is 3 times 2 times 2 times v times v. You know you've done it right if you can multiply across this bottom line and get back what you started with. 3 times 2 is 6, times 2 is 12, times v is 12v, times another v is 12v squared. So that's 12v squared. That's the prime factorization. All right, now I've got to do the prime factorization of 18v. Again, the first thing I'm going to do is break up my coefficient and my variable. That variable has nothing else that needs to be done, so now I can break up 18. The first thing that comes to my mind is 2 times 9. If you put 3 times 6, that's fine too. But now I'm going to keep going. I'm going to bring my v down with me, and I'm going to keep going because 9 is 3 times 3. So the prime factorization of 18 is 2 times 3 times 3 times v, because 2 times 3 is 6, times 3 is 18, and 18 times v is 18v. Now remember, the second step is to go through and identify which ones do these two have in common. So I'm going to break out my highlighter here, and both of them have a 3. So I'm going to pair up those 3's. They also both have a 2. So I can pair up those 2's. This one has another 2, but there's none over here. So then the next thing they have in common is I've got a v here, and I'm going to pair it with this v here. I have another v, but there's nothing to pair it with over here. So that means that my greatest common factor, in order to find it, I'm going to take the things that are highlighted and multiply them together. 3 times 2 times v. Well, 3 times 2 is 6, times v is 6v. When you're finding the greatest common factor, guys, basically what you're finding is what is the biggest number that I can divide both of these by and not get any fractions or decimals. So I can divide 12v squared by 6v. I'd be left with 2v. the things that are left behind. I can divide 18v by 6v. I would be left with just the 3 because 18 divided by 6 is 3 and the v's would go away. So 6v is the biggest value that I can divide both of these by and still have non-fractional answers. All right, so let's do another example. This time I have 3 terms, but the process doesn't change at all. I'm still going to take 2x squared and do my prime factorization, so break it up into 2 and x squared, and then that becomes 2 times x, and then I'm going to go do the same thing to 6x. 6x becomes 6 times x, and 6 is 2 times 3, and then I've still got that x. And then 8 is one of the most annoying ones to do because you do it so often and it takes so long. When I break 8 down, 4 times 2, it doesn't take a long time. It just feels like, I don't know, all those 2's annoy me. I don't know why. All right, so I've got 2 times 2 times 2. When I go through and I look for my common factors here, the only thing that they all have in common is there's a 2, and a 2. These 2 both have x's, but the 8 doesn't have an x. So the only thing they have in common is 2, which means my greatest common factor is 2. There's nothing I need to multiply it by. It's the only thing they have in common. Notice that the only thing I could divide all 3 of these by is 2. If I divided this by 2, I'd be left with x squared. If I divided this by 2, I'd be left with 3x. If I divided this by 2, I'd be left with 4. So it leaves me with whole numbers on all of them. All right, that's all I've got to say. You guys go ahead and try finding the GCF of these different sets of numbers. Don't forget to check your answer, and then when you are finished with these U-tries, you can go ahead and move on to your practice. Make sure you check yourself and let us know if you have any questions because we'll get ready for a mastery check. Bye-bye.